Hello students, welcome back to the distributed system sessions. Today we are going to discuss about distributed commit and recovery strategy. Now in this previous session also we have discussed about n number of communications where we are entered with the client server communication and the group communication. Now when we have such kind of environments together, we say how the systems are manageable if we are having n number of processes where all the processes should accept our request, right? So when I have one application enabled with 100 processes, if one of the process is not ready also, whole application will be shut down mode. Yes, so for such kind of things, how the distributed environment will be working with us to make our application readily available, readily executed when a client asks for such kind of application. So thus, at that moment, how the systems with all the processes will be taken the permission, are you ready or not, first of all. So for such kind of informations, we should go with the commit kind of distributed environment. Now, what is recovery? When we have a processes available, but if we have faced any difficulty while we are executing that application, at one moment process 32 failed, okay, or else process 32 are under erroneous situation or else under fault tolerance. So we have to maintain that back to the proper executable state, I mean the correction state back. So how to maintain that will be there in the recovery procedure. So for that kind of things we need distributed commit and recovery. Now here group communications will be done with the multicasting. So when we have multicasting environments, we will be having atomic multicasting. So what do you mean by atomic multicasting? As you all know, in the database management system, we will be having the ACID properties. So you all know ACID properties will be the combinations where we are making our transaction to execute to the commit state or to the abort state. Any one state we are going to maintain at that moment, right? So for that, atomicity will be playing the important role. So what do you mean by atomicity? Is nothing but transaction should be taken place one step after the other step. After the, we are going to maintain everything in the queue format, right? So if one of the execution done, which is there in the Q1 part executes first and it gives a proper successful, then only we should enter to the Q2 part, right? So that is what the atomicity will be playing important. After process 1 executes successfully, we should enter into process 2. So in such way, if all the processes of our application gets successful execution, then we will be committed with our execution, right? So for such kind of things in the commit environments, we should know what is atomic multicasting first of all. So that is the environment where we are discussing about the atomic multicasting. Now in the commit strategies, we are having 3 phases. So why these commit protocols are required, we are going to see now in detail. First of all, what is distributed commit? So commit is nothing but we are going to operate our scenario or as application which will be sent in a group communication, which will be sent to all the receivers or else none of them, right? So when we are taking the acknowledgements back, we should get acknowledgements from all the receivers or none of that, or else if all the receivers give the successful replies, we should commit the transaction or else we should abort the transaction. So there is only one point, either yes or no, right? So that is what the distributed commit will say to us. If an operation is there to perform, we are going to take the action of all the group members or none at all. So that is what the distributed commit is. Now there are 3 commit protocols. First one is 1 phase, 2 phase and 3 phase. So when we are in the 1 phase commit protocol, there is only one agenda, that we are going to maintain atomic multicast. So as we'll just discuss what is atomic multicasting. So atomic multicasting is nothing but we are going to save everything in the one queue. We start executing the processes one after the other, right? So when one of the process fails in between, no other process will understand that this process has been failed. Right. So finally, we will be under thinking mode that the client will be in assumption that I may be executed at this point, and he will be under waiting mode for all the time. Right. So there is no proper data stored, either this process executed successfully or not, because there is only one way, that is queue format, we are going to execute the procedure. Right. So this is having a major disadvantage where none of the performance of the operations are registered properly, means we cannot understand which process has been failed at that moment also. So for such kind of things, we are going for the two phase. The best solution for the one phase is to move to the two phase. Now coming to the two phase commit protocol, it is the best thing to execute properly, but we'll go with the disadvantage also. When there is a possibility of blockings, then there arises a problem with the two phase. So now we'll enter what is two phase first of all. See, two phase is nothing but we will ask all the members of the group to select one coordinator first. So we have known about many algorithms to choose the coordinator, election algorithms and all in the previous session for the mutual exclusion kind of things. You just review all those once again. Now select one coordinator first to all the group members. After the coordinator is selected, coordinator will be sending the OAuth request. When it gets striked with one of the application requests from one of the client, immediately coordinator will give the OAuth request to all the members of the group. Right. Now all the members of the group must give either OAuth commit or abort as a reply. See, all the members of the group, if there are 100 members are there, 99 members gave OAuth commit because they are ready to execute, and the 100th one gave abort because it is not ready to execute at that moment. So as one of the member has given the abort state, thus the coordinator will be accepting all the requests of the commit, OAuth commit and OAuth abort. So one of the request is abort, right? Response is abort, right? So whole transaction will be aborted as a global abort message to all the members, because we are not going to execute because one of our process is not ready. We are not going to execute at all. If 100 processes give OAuth commit response, immediately the coordinator will be giving the global commit, because you be ready to execute now. All the processes are ready. We will execute now. Right. So we are making all our systems to work properly. Right. Now, when the problem arises, just now I have said, when we have sent requests to all the procedures, done, and everything gave OAuth commit, OAuth abort, something we have received, and one of the process is under crashed mode or if something happened to that process, it is not responding back. The coordinator will be keep on waiting what may be the response I may be getting from so and so process. So this is a possibility of deadlock situation where all the processes will be under waiting mode. See, all the members who has given OAuth commit will be waiting for the global commit or global abort, right? And coordinator will be waiting for the response from so and so process, either OAuth commit or OAuth abort, right? So this will be in the dreaded deadlock. So the situation in the distributed commit protocols, dreaded deadlock is nothing but coordinator will be keep on waiting, but the process is not responding. And remaining all the processes who gave response will be waiting for the coordinator call, either global commit or global abort. So this is a situation where the 2PC will be having a lacking, right? So why the name 2PC? There are two phases, right? Either commit or abort, global commit or global abort. And in that also we have two phases again, voting procedure and giving the global commit or abort situation. So this is named as a two-phase one, right? So this is what the thing which we have just discussed. We are going to initialize procedures, then and the coordinator will be giving the OAuth request to everybody and it will be under waiting mode. After receiving everyone with OAuth commit, it will give back global commit. If one of the process gives abort, abort, then the overall message, global message will be the abort. Similarly, this side also, when we will be giving the abort state by one of the abort states. See, this is a procedure which we follow at the coordinator end. This is a procedure which we follow at the participant ends, means every member of the group. This is a coordinator procedure, this is every member. See, every member will be readily available. They may be getting vote request or response from the coordinator. So it may be giving either ready mode by the commit or abort. Okay, so there are two phases only, right? So the main thing is, if any system or a process crashes in between, there arises the problem of dreaded deadlock. So for that situation, the main solution is the three-phase. Now, in the three-phase, there is simple scenario that there will be three phases. One is the voting procedure which gives by the coordinator. Second one, after everything gets ready, globally, this coordinator will be making all the processes prepared to start. Okay, so we are making in between the third phase, that is a prepared to start. We should be ready to start. And the last one, you should start the commit. So that is the three phases we have. So when we have vote request sent to all the processes, all the members, if any member is not readily available, and every member will be giving, I am ready to execute, I am ready to execute, so prepare to start message, but one process is not giving that message also, so it is not ready to execute at all. So thus coordinator will understand that something has happened, so we have to give the message global abort to all the processes immediately after 2 to 3 minutes after the given time stamp of that particular coordinator which is maintaining. After that particular timestamp, the coordinator will be giving the global abort immediately without going into the deadlock situation, I mean the starvation concepts and all. So without entering into that, the 3PC will be the best solution to maintain such kind of things. So the final decision will be taken only after pre-commit situation. See, I have given all the vote requests and everything, and if it is abort state, we are not doing anything. If all the processes are given with the vote commit and all the processes are waiting, what may be the thing which I am getting from the global coordinator, right? So global coordinator in between, it will be giving us pre-commit message. After getting that, if any abort situation or if any process is not responding, immediately it will stop that by giving the global abort option. Very simple thing, three phases. Now the last concept is the recovery. So coming to the recovery, when we are under the process execution, if any process fails, immediately how we are going to deal with that is a process strategy, I mean the recovery strategy in the distributed environment. Here you will be having two forms. First one is a backward, second is forward. So what is backward? Backward is nothing but after every successful execution in the atomic processing, we will be maintaining the checkpoints. Okay, so if we are failed at the checkpoint 3, we will revert back to the checkpoint 2 and we will start execution once again from that. So that indicates that whenever we have one failure, we will go to the previous step and we will execute from there. So thus we will be not even enter into the erroneous prone at all. So coming to the forward, once error occurs, once we are into the fault scenario, how to make our system to execute correctly with that system. So after we get the error, we are going to recover it with the making our system to enter into the correct state. That is what the forward recovery. The major disadvantage with the backward is nothing but maintaining checkpoints is a major point. I mean the save points, we should have the save points, right? So that will be very expensive. Coming to the disadvantage in the forward, we will be entering into the error prone, right? So if we can revert back from that error into the correct state, that will be a good thing and it will be the best thing. But if you are unable to get back, so overall transactions or the overall application gets crashed. So these are the few recovery procedures. So what is the thing? We have maintained few checkpoints over there. If any failure happened in the durability concept, so again we'll go to the previous checkpoint and we start executing it. So very simpler thing. If you have any doubts in this, please be free to contact anytime in the college. Thank you.